I'm audible, right? Okay, so how many of you from the last year batches? Fine. Okay. So I think, yeah, so you know my strategy and like how I teach. So we will go with that, and along with whatever the things you have covered last year, definitely you have to work on. You have to add few more things, right? Just check it out whether my screen is visible to you or not.
Hello, Moto.
If you can see my screens, fine. So guys, here before starting, let's discuss about the syllabus part that we have to cover. Some of the standard textbook that we will be referring for fluid mechanics, right? Here we will talk about the first of all FM syllabus for aerospace, right? So when you see the section 4, that is aerodynamics, in that aerodynamics you have core topics. Apart from this fluid mechanics, you have some other topics also, but I will be dealing with this basic fluid mechanics, right? Here when you see, so I will be dealing with the basic fluid mechanics. In the basic fluid mechanics, now in the basic fluid mechanics, we will be having the conservation laws, right? That is mass and momentum and energy conservations, and we have integral and differential form, right? I want to say that basically continuity equation, right? Any of you in the class, whether you know about the continuity equation or not, you might have studied in the BTech. Yeah. So most of you guys know continuity equation, that is a mass conservation, right? And basically we use that. That is a very basic thing for the fluid mechanics, right? Because mass cannot go anywhere. Mass cannot go anywhere, right? It has to be conserved. Now that is the one thing. Second thing will be momentum conservation. Can you tell me? See, by the mass conservation, we are getting the continuity equation, right? By the mass conservation, we will be getting the continuity equation. Continuity equation. Can you tell me by momentum conservation or by the momentum equation what we are getting, which type of equation we are getting? Yeah, that is fine. That is drag force you will be getting. But once again, if I just say by the momentum equation, Navier-Stokes equation, correct? Right. And of course, we have the energy equation. Whenever we will be dealing with the temperature changes or heat transfer, we will be dealing with the energy equations. Then we will be having dimensional analysis and dynamic similarity. But but basically, when we say these things, precisely we are dealing with this core fluid mechanics topic they have mentioned. Definitely, you will learn this mass, momentum, and energy conservation once again done by the aerodynamic faculty also, right? So that is not my main aim of basically things are to be covered in this class. We will be covering the basic fluid properties, right? Fluid statics, fluid kinematics, right? That is not mentioned in this particular one, but basic fluid mechanics that will be covering that will be covered already in this one, right? Of course, in the fluid kinematics, whenever we will be starting with the mass conservation, momentum, and energy. But this dimensional analysis and similarity is a separate topic, separate chapter, right? So basically, if I'll write the what fluid mechanics syllabus that we will be covering, that is the official syllabus. What you are observing, that is a very official syllabus from the gate website, right? But fluid mechanics for aerospace, if I say, so what are all the topics that we have to cover? The first one will be fluid properties. Second one will be fluid statics. The third one will be fluid kinematics. The fourth one will be fluid dynamics. The fifth one will be the laminar flow. Again, in the laminar flow, we'll be discussing separately each and every topic, that is case by cases. One case will be fluid flowing between the two parallel plates, the fluid flowing in a pipe, and of course, we have the cuvette flow, right? Again, we will discussing each and every topic, but you have to be a little bit patient, right? Sixth one will be flow through pipes. Seventh one will be dimensional analysis and similarity. And similarity. See, similarity, we are not having only one type. We have the three types of similarity, right? But in the syllabus, they have mentioned only one, right? We have geometric similarity, kinematic similarity, and dynamic similarity. But why they have given intentionally this dynamic similarity? Because whenever you satisfied for any system, for any what we say prototype and model, when you satisfy this dynamic similarity, automatically your other two similarity, that is what we call geometric similarity and kinematic similarity, will be satisfied. We will come to know about that in detail in seventh chapter, right? In chapter number 8, we will be dealing with the topic called boundary layer theory. Boundary layer theory. The ninth one will be the basics of the turbulent flow. Basics of the turbulent flow. And remember, guys, one more thing I want to add, because some of you might be feeling that, sir, we are basically moving towards the excess syllabus. Even in our syllabus, that is mentioned only 3 line syllabus, but you are telling 9 particular chapters, right? That is not the case. See, whether in the previous year, in the past, or whether in the history of the aerospace, whether they ask the question from that topic or not, we are not bothering. Basically, my style of teaching will be, I will be covering the topic which is gonna be asked in next year, right? So basically, whenever I used to teach, I used to keep in mind that what are the probability of any topic or any syllabus or any particular question that can be asked in gate 2024. 2023, whether they ask for 1 mark, 2 mark. 2022, whether they ask for 7 marks, 8 marks. Whether in the history in the last 10 years, whether the fluid mechanics has been asked or not, that doesn't matter for next year paper. Because whatever the IT professor is there, he will not see whether I have asked this fluid mechanics this question, that question, nothing. He will be simply throwing the question, right? And who knows, the question will be coming from flow through pipes, and that is the most negligible topic for being neglected by the what aero candidates. Getting my point? So remember, whatever the things we are learning, you have to write each and every point, each and everything, right? Now, regarding the most important topic that we have to cover is boundary layer theory. That is the very important. I will be keeping 4 star. Dimension analysis and similarity, I will be keeping here once again 4 star. 4 star means very important, right? And then fluid statics, again 3 star. Then fluid kinematics, you can just keep it 3 star. Fluid dynamics, once again you have 2 star. right? The laminar flow, once again, 2 star. Fluid property, 1 star. Flow through pipes, again 1 star, right? Basics of the turbulent flow, again 1 star. So these are the star wise priority you have to set. The boundary layer theory, definitely one question will be there every year. Whether you just see the 5-year paper of the last 5-year paper of the aerospace, one question is there from the boundary layer theory, whether it is of 2 marks or 1 mark or maybe 3 marks, sometimes 3 marks also. Dimensional analysis and similarity is a most hot topic, or what I can say, in gate examination regarding fluid mechanics. Every year, one question is there. Right? This year also we have 2 mark question, right? From this dimension analysis and similarities. Then we have the laminar flow, right? Flow through pipes only once they asked 2000, in 2014 for the aerospace. Fluid dynamics, again, Bernoulli's theorem. Definitely that is a very, very useful, that will be covering. Fluid kinematics, what is a streamline, what is a streak line, right? What is the path line? These are the topics we're gonna cover. What is the velocity potential function? What is the stream function? These are the topics we will be covering in the fluid kinematics. Fluid statics, what are all the Pascal law? What are all the types of pressure, right? Absolute pressure, gauge pressure, you know, vacuum pressure. These are the topics we are covering in the fluid statics. Fluid properties and some fluid laws that we are covering, that is Newton's law of viscosity. These are the topics, that is a very, very important. Even fluid properties, you can just keep it 2 star, right? Now, because here, you might have seen the topper also getting the marks, not more than 65 marks, in especially in the aerospace. When you observe out of 100 marks paper, have you ever thought that why the aerospace students are not able to get more than 80 marks or more than 75 marks? Because most of the topics is being neglected by the topper also. Getting my point? But we have to study. If you see other branches, they are basically rigorously studying each and every corner topic also. That's why in the mechanical you will see above 90 marks, the topper. But aerospace, once it is started from 2007, I have not seen anyone who is getting above 80 marks. Again, I'm not saying that is a very, very impossible thing. Again, that is a very hectic one. But if you try and if you just cover each and every corner topic, because you have started your, basically syllabus from Feb only, so it is very much possible, right? Within the 1 year, you can able to cover each and every corner topic, and you can get any marks. So don't see previous trends, whatever it has been asked, you just erase it and throw it into the what? Garbage, whatever the garbage is there, right? And whatever the things are there, you have to keep in mind that what are all the topics that is being frequently asked. You have to study very carefully, right? There should not be any chance of doing the mistake in actual gate examination from that particular topic. Then only you will be getting above 50 marks. That is a very, very easy thing for you, irrespective of the whether the paper is tough or whether the paper is easy. Now, so that is a syllabus regarding aerospace. Now, how many of you are from mechanical? If you can just tell in the chat section very quickly, so that we can start our topic called fluid properties, chapter number 1. Any one of you, anyone from the mechanical here? Mechatronics, fine. So FM syllabus, if you see for the mechanical, right? So fluid mechanics and thermal science, that is a big domain here we have. But when you see from the fluid mechanics syllabus, once again we have the fluid properties, fluid statics, forces on the submerged bodies, stability of the floating bodies. Now, once again in aerospace in 2000, I think in 2020, they have asked one question from the Archimedes principle also. In the past, I can say 16 years, they have not asked single time. Only one time they asked from this, what we call submerged bodies cases, right? So what we can do? Nothing we can do, right? So control volume analysis of the mass, momentum, and energy, fluid acceleration, differential equation of the continuity and momentum, Bernoulli's equation, dimensional analysis, viscous flow of incompressible fluid, boundary layer, turbulent flow, flow through pipes, head losses in the pipes, bends, fittings, and then we have basics of the compressible fluid flow. The basics of the compressible fluid flow is also there in the what? Aero syllabus, right? It is also there in the what subtopic of the aerodynamics. Getting my point, all of you? Yes or no? Whatever you are observed, this core topic, that is a core topic number one in aerodynamics, or I say A. If you observe the aerodynamics syllabus of aerospace, one topic is fluid mechanics, other topic is what? Compressible fluid flow. Yes or no, guys? Yes or no? Yeah. So these are the basically syllabus part. Whatever the mechanical syllabus is there, almost this is only is there, right? There is no extra thing. But in our class, in the fluid mechanics class, which is going on, that will be continuing for the upcoming 12 classes, you have to remember one thing. We are covering the common part, which is common for both mechanical as well as aerospace, right? So moving towards the standard reference book, because uh, we have to practice from somewhere, right? So that is a very, very important thing. So the standard reference book, I would say, how many of you are aware of the Sinjal and Simbala textbook? Unit A, Sinjal. Basically, it is known from Sinjal and Simbala, right? Yeah. This you have to refer. I will be telling you the purpose also for each and every textbook. Let me write. Then you have the Frank and White, FM White, correct? Then I will be telling you the song Biswas and Chakraborty, right? These three are the IIT professor of the IIT Kharagpur. These are the legends of microfluidics or fluid mechanics or whatever the aerodynamics you say. And then we have the K. Subramaniam, and then we have the R.K. Bansal. Now we should not follow R.K. Bansal because some of the things are not given accurately or precisely. Even some of the concepts are a little bit wrong. But still, I will mention that book for some reason. I will tell you. Now, initially 30-minute guys, we will be discussing the syllabus part and weightage part because that is a very, very important. Even for this course will be containing only for 2 to 3 marks or 3 to 4 marks for the aerospace, but still it is very important. Why? Because whatever the things we are learning, that is applicable for all the subjects. Whenever you are starting any topic, any subject, you have to keep in mind that from where I need to practice, what are all the things I need to practice, and up to what depth I need to cover the topic, right? Now, for the concept understanding, I would say the Sinjal is one of the best for concepts, right? But for the numerical also it is very good, right? But especially what we observe that student used to follow for the conceptual clarity, they follow Sinjal, right? Even for the interview purpose also, it is one of the very, very, very good book. FM Void, that is a concept plus numerical. And believe me, if you after my classes, if you read fluid mechanics, you will be basically enjoy like anything reading this particular book because that is the FM White basically covering the beauty of the fluid mechanics, right? It is way beyond the imagination that you will ever imagine about the fluid mechanics, that in what depth they have given the each and every topic. Initially, when you read that, you will feel I'm not able to understand even a single line also. But after my 12 classes, you just go through that book, and that book is not helpful, not only helpful for the fluid mechanics, but aerodynamics. Also, if you want to cover some of the Navier-Stokes derivation or anything, you can cover from that particular book. Correct. Subramaniam, we have the thousand problem, right? Basically, this particular Subramania book is is to be followed for only and only what? Problems, right? Only for problems. But while discussing the suppose if you are solving this particular what is called Subramanyam, you have to keep in one thing in your mind. There is a mistakes, right? A lot of mistakes in calculation, not in the question, but in the calculation, or maybe and in answers. So you have to verify from your friends, right? You have to share the questions so that whatever the answers you are getting, if they are also getting the same answer, then you can finalize it, right? RK Bansal, I would say, for very basic numerical, for basic numerical. Sometimes we used to study so many hard things, so many hi-fi things that we forget to learn very easy thing. And in gate examination, basically they are testing very easy thing plus aptitude in every topic. They do not expect that you learn some rocket science thing and you just come up with the on the final day with the some very high profile kind of solving practice questions, and so you solve every question in what you call 1 minute. It is not a fundamental thing of conducting gate examinations. No, whether you are knowing the basic thing with little bit of understanding of that particular topic or not. Now these are the champion of the fluid mechanics, and basically what we say for mechanical, it is a bible. For mechanical, it is very essential. For fluid mechanics, if you are practicing, it is mandatory. For mechanical guys, whoever attending this particular session, SOM and whatever you can say SK SOM book is very important for fluid mechanics. Remember that. Without that, you cannot basically go to the gate examinations directly, because direct questions are coming from this book. Direct questions are coming from this particular book. That is a very important thing. Directly questions are coming from this book, right? Because they are only the framing the questions for actual gate examinations, right? Whether these things are clear, tell me guys. And regarding my particular content, whatever the content I have prepared from the Sinjal and Simbala textbook, right? So if you are following my classes, you do not to worry about the textbook of Sinjal. If you want to refer furthermore, you just refer FM White, right, or SK Song. And for solving the numerical, again you can follow FM White, Subramanyam, or RK Bansal, right? And you know that for you guys, the Bible for the aerodynamics is what? Anderson book, right? Yes or no, guys? Anderson book, whatever the book is there, that is a Bible for you guys, right? Regarding the aerodynamics, you can follow that particular book also. But after my classes, you try to go through all the books. You will be reading with the open eyes and with the all the understanding, and very easily you can cover and very quickly you can cover all the pages of that book, right? Now, so this is regarding the textbook. Now coming to the weightage part. Now regarding the weightage part, regarding fluid mechanics. So here, what I will say for aerospace, I'm not including any topic other than this what we call FM, right? In aerodynamics, you have 4 topics. So I am just covering only one part of the topic of the aerodynamics. For aerospace, usually it varies from 3 to 4 marks, right? But surprisingly, in GATE 2022, it has been asked was only 7 marks, and 3 to 4 marks they have covered from the fluid statics only. right? So anything in any particular year, anything can happen. You cannot predict that, sir. It will come on. It will come only for this many marks, and this particular marks. It is just a general thing that we should keep it in our mind, right? For mechanical, it is basically varying from 6 to 9 marks, right? So this is regarding the weightage part. Now I will not take much time and let me discuss the sources for practicing the questions. What are all the sources for practicing the question, guys? Right. So first is IGC notes and whatever the questions we will be covering in the class. Right. Second one will be the gate previous year question. The third one will be NPTEL assignment question. NPTEL assignment question. And then fourth is a very important test series. Right. Those who are getting the rank, whether they are telling ABCD or whatever the things, they would have written this test series very seriously, and many test series they would have written. Those who are getting the rank below 30. Without that, it is impossible. Whether you know aptitude, whether you know about the topic or not, it is one of the very important. So regarding a star mark, I would say this is a very important 5 star, and of course this is a 4 star. Gate previous year question, once again, it is very important. NPT assignment, I would say it is a very important. Why it is very important? Why I have given so many stars? Whatever the question till now you have seen in your original gate papers from the fluid mechanics or from any topic, flight mechanics, structure, or any other topic, they have directly copied from NPTEL assignments. Directly the questions are picked for gate, because that is being these assignments are basically what these assignments are prepared by the IIT professors, and they are actually the one who is preparing the actual gate question, right? So instead of wasting the time, too much time, they will be directly taking the question and they are modifying a little bit, right? So this is a very important. Yeah. And fifth one is a very important, and that is not known to anyone, but I would say this is nothing but engineering services previous year question of regarding if I take strength of material as well as heat transfer. So regarding this SOM as well as for fluid mechanics, you guys can follow ESC. Why it is important? Because for MSQ, whatever the MSQ questions are there, more than one correct. This type of pattern already being introduced in the ESC. So directly you can follow, right? I'm coming to that. I'm coming to that. So sixth one will be again gate previous question of what? A, and you can also follow XC. You can also follow mechanical. You can also follow civil. So I think these are the sufficient enough to keep you in track, or maybe keep you busy in always practicing the question. Getting my point, guys? All of you are getting my point? You will be always busy in solving the question when you just have this many sources, right? Once you have IGC assignment also, we have the IGC assignment also. Now, what is the importance of IGC assignment? IGC assignment's important is that this assignment has been prepared from the standard textbook, standard books. So what is the benefit of basically practicing the question from the IGC assignment? See, when you see the textbook, any topic, you have infinite number of problems. At least 50 problems are there regarding one topic, but you will not be having sufficient time. You will not be learning only fluid mechanics for a whole year, right? Instead of solving 50 questions, you solve only 10 questions from IGC assignment, because they have selected the question out of the 50 questions that is most relevant and most challenging one, right? Because if you solve from 1 to 50 question, you will not be knowing whether I have repeated the same problem, whether I have just doing the problem that is not relevant, that is a very very tricky one, very tough one, whether that is important or not. So to confuse, basically to clear all those confusion, you follow this IGC assignments. Getting my point, all of you? Tell me, guys. Because sometimes what used to happen, why I have mentioned all the branches. Sometimes they used to take the question from A into the mechanical, from mechanical into the aero, from XE once again to A, especially strength of material. Right. This year mechanical one question is there regarding the pressure. The finding the pressure, particular pressure value at a particular location X and Y. That question they have copied directly from aerospace last year question. Just only data changes are there, that's it. Except everything, data particular for velocity profile, whatever the velocity vector they have given, that they have changed, but everything remains same, right? So definitely you have to follow. In fact, civil also you have to follow whatever the, if you just take the civil gate previous year question, you just take whether that particular topic is there in your syllabus or not, whether I have mentioned in our syllabus or not. If it is not mentioned, no need to solve. If it is not mentioned in aerospace, but it is given in the mechanical question, no need to solve that question, right? Unnecessarily you will be wasting your time, right? Getting a point or not? Tell me, guys. Is that clear, all of you? Shall I move to the first topic called fluid properties, chapter number one? Note down chapter number one. Case series is very important. Whether weightage in 2020, 2003. Why? No, aerospace has been started from 2007 onwards, right? 2023 weightage was given for fluid mechanics 3 marks. One question from momentum thickness, one question from the dimensional analysis, right? So note on the chapter number one. Chapter number one, that is properties of the fluids, right? Fluid properties. What are all the properties like a density, viscosity, thermal conductivity, right? These are the things that we have to study. Now, guys, once again, before developing the understanding for fluid mechanics, see, few things we have to know, right? Few things we have to know. After understanding the fluid properties, here, what are all the, before understanding fluid properties, let me just tell you a little bit about the fluid mechanics. And whatever the discussion will happen, in each and every slide will be important, guys, right? Will be very very important for gate examinations. You cannot especially in my classes, you cannot neglect any single slide, right? You can verify from the last year students, those who have attended my classes, each and every slide we all we have seen the question in 2023, right? Especially if I talk about the strength of material, which is having the high weightage this year, you know whatever the slides question we have discussed, even though the deflection question that is being asked, we have already covered in our particular batches, in our particular slides, right? Now, fluid mechanics, in this one we are going to cover what is mean by mechanics. Most of you guys have learned the engineering mechanics, so can you just tell me what do you mean by the mechanics? Mechanics dealing with the only motion or what? It is a study of effect of forces, right? It is a study of effect of forces. Effect of forces. Now, when I say here study of effect of forces, here you might have seen the body which is undergoing the motion, or you might have seen the body which is under the rest condition, or you might have seen the body which is undergoing the deformations, right? Now, if I say here, you will be having scenario where the body is under what? Completely rest condition. You have the body which is under in a motion condition, and you have a particular body which is undergoing the deformation. Anyone in the class can tell me, in the engineering mechanics, out of these three, what you have studied. What? See, so basically you have covered these two things in the engineering mechanics. In the engineering mechanics, you have covered these two particular things, right? You have not covered any deformation. If I talk about the deformations, we have the different types of deformation: finite deformation, infinite deformations. But we have not talked about anything regarding deformation in the engineering mechanics, because we are dealing with the rigid bodies, non-deformable bodies. Engineering mechanics is nothing but what? Dealing with the non-deformable bodies, that we also call rigid body. We also call rigid body mechanics, right? Now, but my dear friend, and what are all the things you have covered in the strength of material? Like we will be covering in the strength of material. What are all the things we will be covering in the strength of material? This one, strength of material or mechanics of solids. We will be covering the deformations. There we will be dealing with the elastic deformations. Elastic deformations we will be covering in the strength of material. Engineering mechanics, we are dealing with the rest as well as motion. That's why we study statics as well as dynamics part. See, for studying this solid body, right? Some and engineering mechanics dealing with the solid body. Solid body means just like a ball, right? If I take a ball, if I take a rod, right? If I take anything which is solid one, right? The solid state of matter we are dealing here, we have categorized two subjects: engineering mechanics and strength of material. But in fluid mechanics, we are studying all these, all three. That means the fluid is at the rest condition, fluid under the motion, and fluid which is deforming. We don't have two particular subjects. All the things, whatever the things you are looking right now, rest, motion, and deformation, all the three things we are covering in the fluid mechanics. Why? Because see, in fluid mechanics, whenever you say motion, right? Whenever you say motion, the motion is not possible without deformations in a fluid element, right? And that deformation where the motion is possible, we generally tend to say it's a shear deformation. Getting my point? Rather to say shear deformation, we say shear deformation rate. Yes or no? Tell me, guys. Now, what is a shear deformation, sir? What is a normal volumetric deformation, sir? You might be feeling difficulty, you might be not be understanding. No need to worry. But as of now, what I'm saying that if you take a solid body, if you just take this solid body, right? This solid body, we might have the volumetric deformations, whatever the deformation is there. But that deformation will happen when the solid body is not under the motion also. But in the fluid mechanics, if you want to have the deformation, they have to, if you want to have the motion, it has to deform. And that deformation has to be very, very continuous, right? Let's see about the fluid mechanics. Here, before starting the topic, just wait. All of you have noted down this one, this particular slide. Is it done for all? this particular slides, right? So fluid mechanics, fluid under the rest condition, we say that is a fluid statics. And whenever the fluid is under motion condition and deforming in the deformation state, we say fluid kinematics and fluid dynamics, right? Now, so yeah. So whenever we say forces, whenever we say guys forces, in the forces particular we have how many types of forces? You know, guys, we have tensile force. Suppose a body is there and we are applying the tensile force, right? Like this. We have the compressive force. Suppose a body is there and we are applying the forces towards the cross section area of a particular body. And then we have the shear force. Shear force means any particular body is there or element is there and we are applying the forces that is parallel to the surface, parallel to the cross sectional area. If suppose this is a cross sectional area, we are applying the forces that is being parallel, right? Now, if you just say in the fluid mechanics what is happening actually, and you will surprise to see. Let me show that. See, guys. Again, I'm not saying that basically some of you might be familiar with the solid mechanics, right? Whether you know structure or not, little bit. That is a very basic thing, like a normal stress, shear stress, what we call some elastic properties, what we call no Young's modulus, bulk modulus, Poisson ratio. All of you are aware of that, correct? So now, if you are aware a little bit, also no need to worry. Here, I want to say, suppose you have the solid body. See, we have whatever the states of matter, right? We have solid, we have the liquid, we have the gases. Any other states are there? Tell me, guys. Apart from these, it's states of matter. Any other matter is there? Plasma. That is the fourth state of matter. But regarding plasma, we are not dealing here. I'm just talking about the solid, correct? Solid, liquid, as well as gases. So, liquid and gases I'm classifying under fluids, and I'm talking about here it is as solid body. Suppose I'm taking one solid body and I have placed this one onto the ground. I have just placed the solid body onto the ground. And what I'm doing, I'm just applying the forces. I'm just applying the forces. When I apply the force that is being parallel to the cross-sectional area, guys, what is going to be happening? It is just like a shear force. It is just like a shear force, right? Now here, definitely this solid body will undergo shear deformations, right? How the shear deformation will happen? The shear deformation will happen something like this. It will take a shape of like this. It will take a shape of something like this. This gamma, what we call shear strain there. This particular gamma, what we call their shear strain, right? Now here, my dear friend, one thing you understand, according to Hooke's law, for the shear stress or for the shear force, what we have learned? We have learned that the shear stress is nothing but what? Force divided by area. That is a shear stress. The shear stress is directly proportional to shear strain. And if I remove the proportionality, I will be getting what? One elastic constant, that is nothing but modulus of rigidity. Yes or no, guys? Yes or no? Modulus of rigidity, or we also say shear modulus. Yes or no, guys? Whether you know or not. Three, we have the four elastic constant E, K, G, mu. Right? One of the elastic constant I'm discussing right now is modulus of rigidity or shear modulus My dear friend, now you only tell me every solid body, whether it is a steel or any rod, any material is there, every material having the finite value or infinite value. Finite value or infinite value? Finite value, 80 gigapascal, 90 gigapascal. It will be having some finite value. If it is having a finite value, tell me this particular deformation, whatever you are understanding, the Sayre deformations, whether that will be finite or infinite. This particular Sayre deformation will be, my dear friend, finite one in case of solid body. In case of solid body, it will be a finite one. But when you try to see very carefully over here, if you take the fluid element, same fluid element, and placed hypothetically on a particular surface, and same amount of force, I'm not changing the force also, I'm just applying the same force as I have applied to solid body. What is going to be happening? What we are observing, that the fluid will be deforming initially like this, right? Even though a very small amount of force is there, right? It will be, my dear friend, you will observe that it will be continuously deforming. It will be continuously deforming. Continuously deforming. This continuously deforming, whatever the continuous deformation is there, that particular deformation only we call fluid flow has begun. Getting my point? All of you are getting my point? Yes. It will never able to regain its original shape, whatever its shape is there, cubical shape. Why? Because there is a no such a called property, modulus of rigidity for the fluid, which is having some finite value. Nothing. It will be continuously deforming. The moment you apply this shear force, it will be continuously under what? Deformation. And that continuously, or in whatever the deformation is there, that will be infinite. Whatever this particular deformation is there, that will be infinite deformations, right? And that's why we say that whenever the fluid flow or whatever the motion is there and deformation, both are connected with each other in case of fluid case, right? So fluid response is little bit different than the solid response for the same amount of shear force. Getting my point, all of you? Is that clear? Now make a note of it. We say tangential force also. Sometimes we say tangential force. So in a one word, if I say define the fluid, so fluids are the substance. Again, in the fluid, both are coming, liquid as well as gases. The fluids are the substance. The fluids are the substances which deforms continuously under the application of the tangential or the shear force. No matter how small is the value of the applied tangential force, that we have to write. Is it done for all? All of you have noted down? See, again, I would say you might be thinking, sir, these are the very basic thing, and we might be knowing by our own also. Then why you are discussing, why you are investing some amount of time? Here, again, I'm mentioning that now GATE examination is all about MSQ, right? And that is our prediction is that from next year onwards, definitely more amount of MSQ will be there in paper to taste the fundamental, to taste whether you understand theoretical way of particular topic very clearly or not, right? Gate is now no more of solving only numerical. Is of basically gate is of not testing only numerical ability, but it is testing the whether theoretically whether you understood this topic or not, right? Now can I move to the next one? Done. Now one more thing here. So fluid definition, just right. Fluids are the substances. Again, we will make sure that whatever the engineering mechanics you have covered, We will be again verifying that here also in our fluid mechanics in our first particular chapter. Fluids are the substances that deforms continuously under the application of tangential or shear force, no matter how small, is the value of applied tangential force. Make a note of it. Then we will move on to the our topic, chapter number 1, fluid properties. See, when you see the NPTEL assignment, any subject, they have directly given the answers. There is a no explanation, right? So definitely you have to work very hard regarding that to get the answer, to see the steps also, whether you have correctly approached for a particular answer, right? Sometimes you students used to get the answer, but the steps may not be correct. Again, that will be the very, very problematic situation. Done? All of you have noted down? Note down. That is a very introduction part. Property. Any characteristic of a system, any characteristics of a particular system will be called as property. Property are to be considered either to be intensive property and extensive property. We have the two types of properties, right? We have two types. One will be intensive property, other will be extensive property. Again, in thermodynamics also you will be learning this thing, but right now if I say intensive property, intensive means it is name itself is suggesting that independent of which one? Mass of the system, such as temperature, pressure, density. That means, and extensive means the name itself is suggesting that extent of that. That means the property which depending on the particular mass of the system. What are all the examples? Total mass, right? Total volume, total momentum. These are the examples of the extensive property. Just note down and understand line by line. Then I'll be just giving you some example. You have to tell whether that is intensive property or extensive property, right? Getting my point, all of you. Why? Because see, whenever you are doing any project work also, in that you must be very thorough with the properties of the fluids. Any fluid topic you're doing, you're doing the research or maybe any project based on the fluid mechanics or aerodynamics, you must be very much aware of the properties, right? Yeah, density I will be telling you. First make a note of it and then we will be discussing. See, whenever you take any example of one particular room or one suppose control volume I have selected. In this control volume, my dear friend, you have the molecules, right? That is not the vacuum. Whatever the room is there right now, you are sitting. Tell me whether air is there or not. Where you are sitting right now and you are watching these lectures, whether air is there or not, atmospheric air. If it is there, can you say that it is not a vacuum, right? We have some air, some gases molecules are there, right? Getting my point. If that is there, my dear friend, right? That particular room I have taken, and in one segment, other segment, I have divided that room by some partition wall. Initially, I have the mass m. When I have divided equally, right? Initially, this particular room is having some volume v, but right now I have divided into v by 2, v by 2. Let's say, for example, if I divide the room into two compartment, whatever the mass will be there, that will be divided or not? Tell me guys, that will be divided. And whatever the air particles is having the pressure value, let's say p-atm, whether p-atm will be divided, or this air molecule will have the same p-atm, this air molecule will have same p-atm, or p-atm divided by 2, will it be same? Yes. Atmospheric pressure which is being exerted by that fluid particle in a room space or room wall, that will be same, that will be same, right? And that particular thing what we are understanding is that, that's why we are saying pressure. And regarding temperature, let's say your room temperature is what, 25 degrees centigrade. After dividing the room by the partition wall, still the temperature will remain same. That's why the temperature and pressure will be classified under intensive property. But you will say, sir, density will depend on the mass. If density will depend on the mass and volume also, then how can you say that it is depending on which one? So the ratio of two extensive property will be intensive property, because we cannot predict, whether it is directly depending on the mass. If mass is m by 2, volume will also be getting what, v by 2, right? So the density will remain same, right? That's why the density will be called under what, intensive property. Rather, to say this way, you can also write the ratio of two extensive property will always be intensive property. Make a note of it. The ratio of two extensive properties, what you're saying? Correct, correct. The ratio of the two extensive properties will be called as intensive property. Make a note of it. My dear friend, if I'll be asking you viscosity, how many of you know about the viscosity? Whether it is a fluid property or it is not a fluid property? Tell me guys. I want to say by fluid property, whether it can change under any other circumstances. It's a fluid property, and you know that we have one term. Now tell me, that property will be intensive property or extensive property? That is a property, we know that. That is a fluid property. But that fluid property is an intensive one or extensive one? See, whatever the air molecules are there, that's gonna have some kind of viscosity. Some value will be there, Pascal second, right? After dividing the room, again, whatever the molecules are there, that is gonna have the same viscosity, right? Why they will be divided? Why they will be getting changed? No. So you can also write viscosity. If I mention the term called specific enthalpy, whether you know about the specific enthalpy, you might be dealing with in the gas dynamics. Tell me, guys. Tell me, that is nothing but intensive property or extensive property. Enthalpy means kilojoule per kg. I'm talking about specific enthalpy. Is specific enthalpy, that means kilojoule per kg, right? We have divided by mass. That will be independent of the mass. So once again, it is coming under intensive property. Anything per unit mass will be coming under intensive property. So specific enthalpy. Let me ask you a few more things. Let's say the velocity. Tell me, guys. Velocity will be, see, that is also a property. Now tell me, rather to say fluid property, we tend to say not flow property, but somewhat related to that. But that is our intensive property or extensive property? Velocity, intensive. Very good. Right. So yeah, make a note of it. What about the kinetic energy of the fluid particles, whether that is an extensive property or intensive property? Total momentum. Total momentum is nothing but what? Mass into volume. Once again, it is depending on the what? Mass. Kinetic energy, half of mv square. Once again, it is depending on the mass. So once again, that is extensive property. Potential energy, mgh. Once again, that is extensive property, right? What about the electrical charge? What about the magnetic field? These are all what? Depending on the particular mass of the system, right? Mass of the system. So we are classifying under extensive property. Remember, electrical charge and magnetic field will be depending on the mass of the system, and that's why we are classifying under extensive property, right? Make a note of it. Once it is done, let me know. So the next concept is very very important. And how many of you are aware regarding concept of continuum? Before understanding concept of continuum, I will be discussing density, specific gravity, and few more terms. Right. All of you have noted down. See the point function. If you say the point functions are properties, but that can be intensive, that can be extensive also. Getting my point? What is the meaning of point function? Which does not depend on the path, right? But if we say heat and work, these are the depending on the path. So that is not the, that is a path function, that is not the point function, right? And point functions are the property, right? Point functions are the properties, but that can be intensive, that can be extensive. Is that clear? Getting my point? Now, yeah, just wait. Let me discuss that. We'll be covering at the end of the lecture regarding this what you are asking, right? Electrical charge as well as a few other doubts. Getting my point? So now here you just make a note of it. Some properties. The first property we are discussing is density. What is the physical significance of the density? Anyone know? How heavy that particular fluid is, right? Density will tell you how heavy that particular fluid is. How heavy the fluid is, right? Right? How heavy that particular fluid is, that is being defined by density. Density is what? Mass by volume, right? And what is the unit? Kilogram per meter cube. In terms of dimensions, what you can write? Kilogram is what? Mass. Ml what? To the power what? Minus 3. Getting a point? All of you. Now tell me effect of temperature on the density. Tell me effect of temperature onto the density. how the density and temperature will be varying, how the density and temperatures are correlated with each other. See, you can follow the ideal gas equation. You can follow the ideal gas equation, but whether it is applicable for the liquid, whether that particular thing will be applicable for the liquid. Under a very low pressure, under a very low pressure, my dear friend, whatever the water vapor is there, that can be treated as ideal gas. When the pressure is less than 10 kilopascal, tell me guys whether we can treat it, the water vapor molecules, as ideal gas. Yes, right. These are the few things that you must be aware of, that because these things are learning in the, you will be learning in the thermodynamics, right? Now here I want to say one more thing, effect of temperature, right, on density. So what is going to be happening when the temperature will be increased? What about the density of the liquid? Experimentally, it has been observed that the density of the liquid generally, I am using the word called generally, decreases. And what about when the temperature is increased? The density of the gases will decrease or increase? Will decrease or increase? Right. So these are the points that you please note down. Now tell me, effect of temperature is more important or effect of pressure is more important onto the liquid? Whether liquid density can be changed by varying the temperature or by varying the pressure? Perfect. So remember the liquid, whether you want to change the liquid temperature, definitely liquid density, definitely you have to change the temperature rather than changing the pressure, because the effect of pressure, whether you increase 20,000 times, the density of the liquid hardly changes. Negligibly increases. Almost same. But what about when the pressure will increase? What about the density of the gases will increase, right? Yeah, whatever Sanjeev you mentioned, bulk modulus. Yeah, of course. For all the liquids, we have the bulk modulus, and the bulk modulus is a property by means of which we can see whether volume or density has been changing by changing the pressure. But you just only tell me what are all the values of that bulk modulus of the liquids, very high or very low? Very high or very low? Because if it is a very high, that it seems to say that hardly the density of the liquid will change, right? If it is a low range, whatever the values are there, then we can say okay, by the data itself it is saying that little bit of pressure changes, the density will change, and we are okay with that. But if it is a very high value, then even though it is having some very high value, even you change further also, that high value is still the density will not change, right? Yeah, that is what we defined one more term, compressibility, right? That is a reciprocal of the bulk modulus, right? And that is almost like a zero for the water, right? Now, what I have mentioned here is that the density of the liquid generally decreases, but in case of water, that is a very exceptional cases where little bit up to 4 degrees centigrade, the density will increase, then further decrease, right? We will see that. Now, note on the second property, that is the first one. Now, note on the second one is specific gravity. We also call a relative density. What do you mean by the relative density or specific gravity? We denote it by generally S. S is what? Rho of any fluid to rho of, or rather to say fluid, I would say here water. row of water, row of liquid to row of water at 4 degrees centigrade, because at 4 degrees centigrade the water is having highest density. And for the gases, the row of any gas to row of what? Air. Getting my point? Because what is a standard fluid by means of which we are comparing? In case of gases, we are comparing with the what? Air. In the liquids, we are comparing with the what? Water molecules. Here, the specific gravity it is defined as it is a ratio of the density of any substance to the density of some standard substance at a specified temperature, right? Usually for water at 4 degrees centigrade, for which the density of the water is 1000 kilogram per meter cube. Because if we change the temperature, my dear friend, at 20 degrees centigrade, the water is not having the density value 1000, it is having 998. But anytime you use the 998, tell me guys, no, right? Correct. So that's why we used to take at 4 degrees centigrade the maximum density of the water, that is 4000, that is 1000 kilogram per meter cube. Now, generally, my dear friend, I'm not applying the ideal gas equation to say that if I increase the temperature, see, ideal gas equation is what? P is equal to rho RT, right? So when you vary the temperature, the pressure you are keeping constant, and you will say it is inversely proportional, right? But here, my dear friend, okay, you can apply this thing, but at a very, very low pressure for the liquid case. Generally, what is happening in the case of liquid, when you increase the temperature, right, the molecules of the liquid will tend to go away from each other, right? Molecules of the liquids or molecules of the gases, guys? Tell me, guys, whatever my statement is there, that when I increase the temperature, theoretically, I am explaining you, when I increase the temperature, the molecules will go away from each other. So what is happening? The volume will be start increasing for our individual molecules, and you know that when the volume will increase, mass by volume, density will decrease. But that is a very theoretical explanation, and that seems to be correct for the gases, not for the liquid. Getting my point? All of you are getting my point? Correct. So let me explain you with the graph for the liquid water. Once it is done, let me know. And one more thing, guys, whatever the reciprocal of the density, what we say, specific volume, specific volume, right? Specific volume. What is the unit of that? Meter cube per kg. Make a note of it. So three things we have learned from this slide. One is density, one is a specific volume, other is specific gravity. We also say relative density. One more thing is there, guys. Weight density. What is the meaning of weight density? Generally, for the liquids also, when you increase the temperature, the same kind of phenomena happens in the liquid also, and you can say accurately for that also, it usually the density of the liquid will decrease. For the water, it is not the case, right? Correct. Weight density is what? Rho into G. Note down. Here I want to say the graph of density of the liquid. That liquid is what? Water with the temperature. For example, here when you see the graph, you will observe that initially it will increase up to 4 degrees centigrade, but generally experiments show that after that it decreases. So this particular where it is increasing, it is 4 degrees centigrade, and then let's say this is nothing but 20 degrees centigrade. Here you have density 1000 kilogram per meter cube. Once again, why this trend is there? when you increase the temperature of the liquid particle, the liquid particle will go away from each other. Because that liquid, then vapor, the liquid will be converted into vapor, and the vapor, water vapor, I told you, when you can treat that, if you are increasing the temperature beyond certain limit, when you can treat the water vapor as ideal gas, when the pressure is very, very low. Remember, we are talking when the pressure is low. When the pressure is high, again the scenario will be different. So when the temperature will increase, they will be go away from each other, then volume will be start increasing. The volume will be start increasing, and for a fixed mass, because mass cannot change, volume will be start increasing for each molecules. Then what is going to be happening? Mass by volume, right? So volume will increase. What about density? Density will be start decreasing. This is what the trend usually happen with the liquid as well as gases. But the typical behavior happen from 0 degree centigrade because of the ice structure and all. Again, that will be discussed by the thermodynamic faculty, right? Getting my point? Usually what is happening this particular zone, if you ask me by the formula, change in density will be happening is that density is the increasing. The density is increasing means what? Mass by volume. Volume is decreasing. Volume is decreasing means what? They are coming closer. Upon increasing the temperature, molecules are coming closer. That is what will be required. We will not be dealing why and all, because that is a separate topic called pure substances, right? That is being dealt by the thermodynamic faculty. If I deal with that, again 30 minutes will be gone, right? Is it that clear, all of you? But basic thing you must be aware, right? These are the important basic fundamental thing. Whether all of you are understanding the subject or not, tell me, guys. Or you are feeling distracted from the topic. See, I used to tell you by the formula also, and sometime we will be discussing by the theoretical explanation also, so that you will be getting the feeling of that topic. Feeling of the topic is very important, guys. Whenever the tricky numerical or anything will be coming, you can attack that question with the full confidence, right? If anything is missing in your conceptual understanding, definitely you work whatever the hard you are hitting, you will not be able to solve question with the 100% accuracy, right? Because every numerical will require some fundamental understanding of that question which is being given. Now coming to the topic, next one, the specific gravity, whatever we have learned, that is a having some unit, or it is a dimensionless quantity. It is a dimensionless quantity, right? Because specific gravity is what? Rho of any fluid or rho of any liquid to the rho of what? Density or water. Density of the water. Here also kilogram per meter cube. Here also kilogram per meter cube. So that's why we are saying that it is a dimensionless quantity. However, in SI unit, the numerical value of the specific gravity of a substance is exactly equal to its density, right? In gram per centimeter cube or kilogram per liter. Generally, what is the specific gravity of the mercury? 13.6, right? Yes or no, guys? So indirectly, if you multiply with 1,000, you will be getting the density. So what I want to say, what is the physical significance of specific gravity? Indirectly, it is showing the density of the particular fluid only, right? Because what is the density of the water? It's 1,000 kilogram per meter cube. Now, weight density, we have to understand what is the meaning of weight density. Weight density we also call specific weight. Weight density we also call specific weight. Note down. The weight of a unit volume of a substance is called specific weight or weight density. Specific weight we also call weight density. It is a weight per unit volume, right? Weight, weight is what? Mg per unit volume, right? Per unit volume. Mass is what? Volume into density and by volume. So this will cancel out. So rho g. And what is the unit? Newton per meter cube. In particular dimension, if I in a dimension form, if I want to show what is the unit of Newton, what is the Newton unit? Mass into acceleration. So what we can write? M lt minus 2, right? Because acceleration can be written as meter per second square, L t minus 2, right? Divided by meter cube, right? So what we can write? Can we write like this? Tell me guys. Make a note of it. Yeah, you can say with respect to with the help of specific gravity, you can say how heavier the liquid or the gas is as compared to the standard fluid. Now, once it is done, let me know. Is it done, all of you? All of you have noted down? Is it done? Note down the density of the ideal gas. Any gas will behave like an ideal gas under which condition? Tell me, guys. At a low pressure and high temperature, or at a high pressure and low temperature? See, whenever we are dealing with the any gases, we are dealing any gas and we are treating that to be as an ideal gas under low pressure. What? You are saying opposite. And high temperature. Please check it out. All of you, please check it out, verify it. Yes, it will be valid under low pressure and high temperature, right? Now, what is the equation, my different ideal gas equation? PV is equal to MRT, right? We can also write M by V RT, where we can write P is equal to rho RT. But knowing the equation is not that important. The meaning is very important. P is what? Absolute pressure. What is the meaning of absolute pressure? Absolute pressure will be equal to P ATM plus gauge pressure. In a fluid statics, we will be learning called concept of types of pressure, right? In that we'll be covering how many types of pressure are there. That is atmospheric pressure, gauge pressure, and absolute pressure. In any particular location, suppose you are living in this place. If I say at this particular point, the pressure is, let's say, we say 105 kilopascal. What is the meaning of that? Whether we are showing the atmospheric pressure, whether we are showing the gauge pressure, or whether we are showing the absolute pressure, that is a total pressure. Absolute pressure, you can treat it like a total pressure. Absolute pressure only. 105 kilopascal, that means it is saying that, okay, 101 kilopascal is atmospheric pressure, and remaining 4 kilopascal is additional pressure, right? At that location, the pressure might be more than atmospheric pressure, right? That's why it is more than atmospheric pressure, right? But at any particular location, let's say in a vacuum space, the pressure is what? Coming it as, let's say 20 kilopascal. Then what you will say? Whether, see, at that location, the atmospheric pressure might be 100 kilopascal, let's say, for example, but it is showing the total pressure as 20 kilopascal. Then what could have been the situation there? Whether there has been a vacuum or what? There has been a positive gauge pressure or negative gauge pressure. See, total pressure you are writing PATM 100. What should I keep it to make it 20? I should make it minus 80. Minus 80 means what? At that location is what? The pressure has been reduced as compared to the atmospheric pressure by 80 kilopascal. That is the negative gauge pressure. That negative gauge pressure we also call vacuum pressure, right? That thing we will be learning. No need to worry. Make a note of it. And what is the R? R is nothing but the gas constant. What is the formula? Ru by molecular weight, molecular mass. Ru is what? Universal gas constant. What is the value? 8.314 kilojoule per kg Kelvin. And from this relation, it is very much clear, for a fixed pressure, density is inversely proportional to temperature, right? When you keep moving away from your surrounding temperature or layer to stratosphere, my dear friend, what is happening? What is happening, guys? Whether temperature is decreasing or increasing with the height? Temperature is decreasing. What about density? What about the pressure value at that location? That is also decreasing. Temperature is also decreasing. Now tell me, what should be the air? That should be thinner air or thicker air? Thin, very, very thin, right? When you keep on moving, suppose you are flying your aircraft at a very, 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 very high altitude. Now tell me one reason. If I'll ask you one question is there, right? One proper question is there. Why aircraft avoid flying over the mountains, or maybe over the Himalaya regions, or maybe you can say over the hilly areas? Why it is avoiding? Why it is navigating towards the non-hilly areas? Can you please answer that? Eh, and you know that hilly areas are at the very, very high altitude from the Earth's surface. Like if I ask a fluid mechanics reason for that, which one? Engine doesn't get the mass flow. Perfect. Correct. Sufficient thrust forces we will not be getting, right? Yes or no, guys? For a particular volume of the chamber of the engine, if density will decrease, what is going to be happening? Mass. Perfect. Correct. So all of you guys are very well aware of the particular topic, right? So you try to correlate, and even I will discuss the proof also, why with the altitude from the earth surface, why pressure, temperature, density is start decreasing. We will be doing the derivation also. Getting a point? So try to connect every answer. Whenever any person will ask you, try to connect with the fundamental topic or subject which you already learnt. Try to explain this formula like dp by dz, sir, that will be e to the power something, some function of what? It is a some function of exponential function of h, right? When you keep on increasing the height, the pressure value will be exponentially decreasing. But it may decrease linearly, it may decrease exponentially, it may decrease by some other way, that depending on the what? Surrounding conditions, whether it is a isothermal layer, whether it is a adiabatic conditions. All of you getting my point or not? That is a point of discussion in the fluid statics, right? Now, so all of you have noted down. For the air, if I say what is the R value, you might be using R value frequently in the gas dynamics. Tell me guys, 8.314 divided by air molecule mass is 28.97, we treat it. So almost, what is the value? 8.314 divided by 28.97, that is 0.287 approximately, right? Kilojoule per kg Kelvin. 287 is joule per kg Kelvin, right? Yes or no guys? Getting my point? All of you. Now, before discussing the viscosity, I would like to tell you one more property that is a very, very important, and that is nothing but concept of continuum. Note down, concept of continuum. And all of you, please tell me in one line, what do you mean by the concept of continuum? That is a very easy topic, but I will explain you in a very, very easy manner. In a layman language, I will explain you what is the meaning of concept of continuum. Perfect. Very good. Very good. So yeah, I'm just impressed with your answers, whatever the answers you guys are giving, because that is a true answer, I would say. Yeah. So Vikas answers, I basically, I totally impressed because you have directly given the a clear picture of concept of continuum. Knudsen number is a number which is being defined for validity of the continuum concept. Yeah. Just like it is zero Knudsen number, so almost no holes, no gap. Now tell me guys, note down, the matter is made up of atoms, right? If I just take one example, in a chamber or a particular control volume, see control mass and control volume, what is the difference? Of course, I have not started fluid kinematics, but still you can tell me if anyone know about that. If I say a control volume, if I say a control mass, whether in case of fluid, is it okay to define control mass? Or is it okay to say for the fluid control volume, which is more suitable here? In case of solid, suppose a ball, that is a, you can treat it like a control mass, right? But in case of fluid, where fluid is entering, fluid is leaving from a particular region, that region we define one space we are selecting for our analysis purpose, and that space we are saying control volume. Getting my point? Correct, correct. So most of you guys are very, your fundamental understanding is very good. Keep your enthusiasm regarding subject like that only for all the lectures as well as for all other subjects, right? Definitely rank will be coming, right? Now here, suppose there is a control volume and we have lot many molecules over here. Of course, I cannot show how closely they are uh, packed in that control volume. See, and one more thing, if I ask you one question, whether concept of continuum is defined for solid, whether concept of continuum is defined for solid, whether concept of continuum is defined for solid. Tell me guys, yes or no? Perfect. Very good. So there's a no need of defining the concept of continuum because they are closely packed structure, right? So hardly any void or gap is there. The otherwise a lot of defects will be there. And suppose we are making any material, we'll make sure that during the casting itself, we avoid any kind of holes or any defect. We make defect free solid materials, right? But usually in case of fluid, that is liquid and gases, especially in the case of gaseous molecules, there might be some gap, right? But we used to avoid that gap in our analysis purpose. Let's see what are all the consequences of those assumptions. Now here, suppose in a control volume we have the lot many molecules, and let's say the molecule number is 10 power 23 molecules. So many lakhs and crores of molecules are there, right? In that molecules, suppose you have defined your system characteristic length to be like this. What is LC? Let me define LC as system characteristic length. Try understanding guys what I want to say from here. System characteristic length, understand. Suppose you have a glass of water, right? You have one glass, in that you have water, and up to full height of the glass you are filled with the water. By default, whenever you look at the water, whatever the glass is there, whether you observe any gap, you can't see, right? You can't see any gap with your own eyes. Even if you take the microscope, also you cannot see any gap. Suppose you are taking the part of the glass, suppose the glass is there and you have filled with the water up to the height of H, for example, and you are looking from here with your eyes. What is happening? There will not be any gap in between the molecules, right? Whatever the water particle molecules are there. But when you look at very carefully, only some part here, suppose, and when you just zoom it, what you will observe that the molecules are having here, molecules are not there, molecules are there, molecules are not there, again molecules are there. When you look at a very very micro level, you will find that density has to be defined here. There is a no density, has to be defined, no density, density is defined. But we also know that density, or whatever the thermal conductivity, whatever the property viscosity, we have defined as a continuous function of space and time. We say density as function of space and time continuously, right? We never say that, okay, at Agra location, at Delhi location, at particular what we say India gate, at that front of the India gate, a water particles is there which is having density 1000 kilogram per meter cube. We don't say like that. Directly we say India gate Delhi, the water particles are having the density of something like that. We never say at a particular location, at that micro level the density is not defined. Why? Just we have to thankful to our concept of continuum. It is saying that even though gap is there, we treat it like there is a no gap, because you are assuming that your system characteristic length is very very low. But when you make your system characteristic length very very high, height of the glass, then that particular gap will be almost invisible. That will not be visible to you, to anyone. So it all depends on what system characteristic length, what is the length of the system as compared to the gap between the molecules. Or we say we define one term called mean free path, right? So if you just observe your system characteristic length over here only, you can observe the gap. But this big large control volume, lot many molecules are there, even though they have the gap, that will be negligible. That's why to define the validity of the continuum, for validity of concept of continuum, we define one number, that is a Knudsen number. What is that? The Knudsen number is defined as, it is a ratio of What? It is a ratio of what? Tell me, guys. It is a ratio of the what? Mean free path to the system characteristic length. Mean free path to the system characteristic length, where lambda is nothing but mean free path. Mean free path. What is the mean free path? Anyone know of this thing? Mean free path is nothing but average distance. Yes, average distance traveled by the molecule. Average distance traveled by the molecule between two successive collisions. Average distance that is being traveled by the molecules between two successive collisions. Suppose molecule A is there, which is being colliding with the molecule B, and then it is colliding with the C molecules. Here, suppose it has traveled the distance S1. Here, suppose they have traveled the distance S2. Now, lambda is defined as S1 plus S2 divided by 2. That means even though if your system characteristic length or system dimension, the room, the glass of the water, if you are taking very, very large, then what is happening? Even though they will be colliding, they will be jumping around from here and there, right? Ultimately, that will be telling you how much of space is available between the molecules. Indirectly, lambda is what? Indirectly, lambda is showing that the gap between the molecules, right? If they are jumping from here to here, B to C, A, B, C, even that also not able to significantly highlight the gap. That means what? Lambda is very, very less as compared to system characteristic length. In that case, we say when the Knudsen number is less than 0.01, then we say concept of continuum is valid. Concept of continuum is valid. Otherwise, if Knudsen number is more than 0.01, what is going to be happening? Non-continuum flow. What we say? Non-continuum flow. Non-continuum flow. Even this particular thing that they can relate to correlate to what? MSQ question. How they can frame question? Let me tell you one question. Knudsen number is greater than, suppose Knudsen number is 0.1, for example. Yeah, I will explain about the system characteristic length in detail. No need to worry about that. Before that, I will be telling you that Knudsen number is suppose 0.1. Right? They can frame the question. Suppose if Knudsen number, again not 10, because it is not justice to that. Suppose Knudsen number is 0.1, for example. Then which of the following option? Correct. A option, continuity equation, valid. B, Navier-Stokes equation, valid. C, Bernoulli equation, valid. D, none of the above. See, guys, so try understanding in our fluid mechanics concept of continuum is will play a very vital role in understanding our fluid kinematics and fluid dynamics. This concept of continuity, Navier-Stokes, Bernoulli, all has been derived by assuming there's a no gap between the molecules. Getting my point? That's how they can play with the topic. Even a small topic, when they will be putting into the actual exam, from there onwards, all the institute will be start framing the question. Right? But after that, what is the use of that? Before that only we should be knowing what are all the assumptions of that equations, right? Assumptions are very very important, remember, for MSQ question, right? If MSQ would be negative, that would be hell like an exam, get exam. But they have given some relaxation that MSQ is no negative marking. But if I would be there as a paper setter, definitely I will be putting negative marking for MSQ, because see, those students who are attempting the MSQ, whether the concept clarity is not there, they will be simply guessing the answer and they're getting the marks. If guess is not correct, no negative marking. But for guessing, there has to be enough penalty should be there, right? That's why it's not only the numerical ability exam. This past 2 years, what we are observing, it is more of what, theoretical understanding, right? Even you can verify this thing in all the subjects. Now, all of you have noted down this thing. That means if I just go into the deep down of this topic, I would say, if I just make a plot of density versus system characteristic length. Again, some of you having the doubt in this system characteristic length, I'll make sure that will clarify. But before that, let me explain one thing: density versus LC. That's again not possible 80 plus, maybe not possible 55 plus, also 60 plus, also even for all India one, if MSQ would be the negative. Now, even not for aero, it will be very difficult for other branches also. Now here, if the system characteristic length is very very high, constant density, very very high, constant density. We see, if the system characteristic length is very 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 high, room size is very very large, glass size is very very high, glass height is very very large, then no need to worry, density will be constant. Density will be constant, density will be constant, density will be constant. The moment you keep on decreasing your system characteristic length, you keep on decreasing system characteristic length, starting from here, and you keep on decreasing your system characteristic length, what will happen? You will observe, what you will observe here, you will find density is there, maximum density is there. But the next moment you will find there is a no molecules, zero density. Once again you will find that particular density value, high density value, once again zero. You will be having the density behavior like this. But we will make sure that LC value at least greater than 100 times of lambda somewhere here, so that almost density will be constant. Not only density property, even though viscosity has to be constant, so that we can define our property. Getting my point? Right? Is that clear? The concept of continuum means there should not be any gap between the molecules. All of you have done with this? Now, guys, the validity of the concept of continuum we are saying, because, sorry, because we want to say, just wait. Why we are defining the concept of continuum? A big reason is what, guys? Tell me. What is the big reason for that? So that we can define property. So that we can define property as continuous function of space and time variable. everything whatever the mathematically the property or the function should be dependent function should be continuous, right? That should not be discontinuous. Getting my point or not? Tell me, guys. When you understand the limit, continuity, and differentiability, discontinuity is not at all very useful for us, right? We want our function to be continuous, right? There should not be any jump. That has to be continuous. There should not be like this. And one more reason is that even though at a micro level you have the gap, you almost neglect that gap. One more reason, so that our analysis will be simple. Otherwise, a lot of complicated mathematical tool will be required. You know. Yes. To define the property, as I mentioned. Now, the system characteristic length is again a very important for us to discuss. System characteristic length is there to tell you the what are all the dimensions, whether length, height, thickness, diameter, what should be the consideration for LC value. Perfect. Correct. Good. Now, in case of guys, understand, in case of if I talk about the LC, what is the meaning of LC? System characteristic length. System characteristic length, what do you mean by that? Now, suppose in case of pipe diameter, in case of pipe, I have two dimensions. One is the diameter and other is having the length. If I ask you for the pipe, yeah, just wait. If I ask you for the pipe flow problem, the fluid is flowing in a pipe, what should be the characteristic dimensions? Whether it should be the diameter or it should be the length. So that is correlated to the fluid property or the variation of the property along which direction it is more significant. See, the length we don't consider, guys. We consider only diameter. We consider only diameter over which you will see the variations, right? When you observe in the fully developed flow, this is a boundary layer, right? In the boundary layer, my friend, after developing regions, you will be having the fully developed region, right? Fully developed region. In the fully developed region, my friend, what is happening? Every time when you see after fully developed region, this is nothing but entrance region or developing region. After that, my friend, we have what? We have fully developed region. In this fully developed region, my dear friend, what is the so special characteristic of the fully developed region? Perfect, very good, 1D flow. That is the one thing. Second thing is also their velocity profile will not change. Velocity profile will not change. Very good, guys. Because when you see from here, the velocity will be the function of a radius as well as x from the inlet section. But when you see from here, after that, whatever the velocity profile will be there, that will be like a almost parabolic in case of laminar flow, and that will be the function of radius. And that we will see in the laminar flow. Now, so after the developing region, the length will not play any important role, even though you increase the pipe length up to further extent, but the profile will not change. Velocity profile will not change, my different, right? That's why, and moreover, when you move along the radius direction, you will observe that velocity is varying, right? Velocity is varying, near to the wall, the velocity is almost zero, at the center, velocity is maximum. So all the variations are happening along the radius direction. So that's why the characteristic length is to be considered as diameter in case of pipe flow. But in case of flat plate, if I say flat plate, for example, what will be the characteristic length? In case of flat plate, flow over the flat plate having the length L, tell me guys what you will consider the characteristic length, whether you will consider width or whether you consider the length. And that is fixed flat plate, the length of the plate. Very good. Because all the variations and important things are happening along the length of the plate. Why? Because see, the velocity profile is keep on developing from here to here. For example, right, when you observe, right, now intensely I have made a very bulky region for the turbulent flow. See, when you move along the length, Reynolds number, what it is saying, rho into V infinity into X by mu, local Reynolds number. So as you keep on marching along the plate, as you keep on changing the length of the plate, Reynolds number will be keep on changing. So length is very, very important. Width over which it is happening is not that important for us. Over the length, the flow behavior has been changes from laminar to turbulent. And you know that in laminar and turbulent, a lot of things has been changed, right? So definitely length of the plate is playing a very important role over here. Getting my point? Tell me guys, is that clear all of you? Now, so all of you might be knowing this flat plate, this diameter, but let me ask you one more question. Suppose you have a particular section which is made up of like this, which is having a dimension B, L, and height is let's say H, and the flow is happening like this. Now tell me, out of this three dimension, which will be LC value for this case? A closed conduit channel in which fluid is flowing, or maybe a square cross-sectional channel in which the fluid is flowing. Fully flow is there, no, not half flow. A fully flow is there. Full wall has been wetted by the liquid, for example. Tell me guys. Once again, when the flow is happening, the top and bottom plate, definitely there will be some kind of velocity variations will be there along the height. So LC will be H over here. And picture will be more clear when we discuss the fluid kinematics, that is types of fluid flow, 1D, 2D, 3D. I will take this example. No, 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 no. H will be there. Getting my point? Seeing the fluid flow directions, only H will be the things that will be there useful for us. Why B will not be there? See, that depends on the end condition, right? See, here bottom plate, whatever is there, that will be the fixed one, and the top one will be fixed one, for example. In that case, H will be important for us, right? In case of suppose this face and this face, the left and right is also fixed one. In that case, B and H both will be important. Getting my point? Tell me guys. See, suppose the top plate and bottom plate I have taken, H is there. So the fluid flow will be happening like this. So at the top and bottom both are fixed. That's why it is getting what? Zero velocity. The variations are happening what? Over the height, right? So in that case, LC will be height. But suppose this particular surface and this left one is also fixed one. In that case, what is happening? The variations will be happening in that side also, when you see from the top view. Getting my point? Understanding or not? Not understanding? See, when this left and right will not be fixed, right? It is just the channel section, right? Channel one, or maybe it is also flowing with the fluid element, then it is of no use. But assume that it is also fixed one, like all the four walls of the channels are fixed, then both B and H will be important. Getting my point? Separately, we have to use to find the Reynolds number based on the H, based on the B, right? Is that clear, all of you? Now, when I take the example of the cuvette flow, then what about the system characteristic dimensions? Suppose we have the two fixed parallel plates. Two fixed parallel plate, my dear friend. Now tell me which are all the important characteristic dimensions. That will be the gap between the plate, right? That is nothing but H only. The width of the plate will not be important. Whatever the width of the plate will be there, that will not be that much important for us. Remember that. Whatever the gap will be there in which the fluid is flowing, that will be the important for us. Is that clear? Right. So the dimensions over which the changes are quite significant, that will be considered as characteristic length. Right. Here the property changes to be considered as significant. That means where we are thinking about the velocities or maybe some other parameters. Is that clear, all of you? So one more property is being left out. That is nothing but the viscosity. And regarding that, we will be discussing in our next class. So till that, if I'll take further 2 minutes, if anyone having any doubt, we can check it out, and then we can wind up. No, which one? If you are considering both as fixed, then which should be considered LC. In case of this one, right? You are asking about this particular example. No, if you just consider less value, then what will happen? Indirectly, you are getting the error in Reynolds number calculations, right? Because what is the Reynolds number calculation? Rho into U average system characteristic length by mu, for example. So yeah, only on LC, but see, that will be the 2D flow, right? That will be the 2D flow, and for the 2D flows, we have to see the behavior in X direction as well as in the Y directions, right? If I take this as X direction, or maybe sorry, this as X direction, this as Y direction, we have to see. Getting my point? We have to consider in both the directions, separate all the things. Whatever the lambda flow we will be understanding, all the things we have to separately discuss for X and Y directions in that case. But generally, whenever the conflict is there between selecting two, we have to select the larger one. Getting my point? Now, guys, so now I think it is clear now why in case of pipe, why we are not bothering about the length, because after certain distance, fluid will become fully double flow, and in that case, velocity profile will not change. So there is a no need to think of length variation. Rather than we have to consider radius variations along the radius, along the diameter, how the variation in the velocity is happening, and that is more important for us. Whether it is a parabola, whether it is a logarithmic, that is important. In case of 3D flow, along which side properties are maximum? See, generally, whenever, one more thing is there, I will be in the fluid kinematics, we will be dealing with that. Suppose we are having the phenomena like this, right? Velocity, fluid is flowing in this direction. So we are considering 1D flow, right? Simple cuvette flow where dou P by dou X is 0. Generally, my dear friend, we used to write the momentum equation. When you write the momentum equation in X direction, we are bothering only in the X direction, right? But when you consider in the Z directions, the property variations are usually considered to be as negligible one. Whatever the variations are happening in the jet directions, we usually perpendicular to the plane of the board, we tend to think of it is as negligible. So one more dilemma is there, that when the dimensions are very very large, infinite dimensions are there in certain directions, in that direction generally the fluid properties varies what almost like a negligible. Getting my point? Internal flows, whatever the gap is there, whatever the diameter is there, that we will be considered. Getting my point? Is that clear, all of you? Now, so whatever the further discussion will happen, that will happen in the next class, right? See, what do you mean by the point function? Now, if I ask you enthalpy, what you will say enthalpy? Whether it is a property, thermodynamic property. Now, if that is a thermodynamic property, let's say, then thermodynamic property is there. Now, that particular property, you only say me enthalpy. That means depending on the mass, that will be extensive property, right? But if I divide by mass, that will become specific enthalpy. That will be what? Intensive property. Getting my point? Tell me, guys. Because see, when you write H, that is U plus PV, for example, U plus PV, all are point function, right? All are point function or not? U internal energy, P pressure, V what? These are the point function, right? These are the point function. This point function might define pressure is what? Pressure is what? That is the intensive point function property. And what about the volume? That is the extensive property. Getting my point? So it can be both. Understanding or not? Getting my point or not? But if we say specific volume, that is a meter cube per kg, if we divide by mass, that will be once again intensive property, right? If we are defining for a point only, then we why we will. No, I'm not understanding. For what? See, point function again. I'm saying that it can be both, right? There is a no meaning of what you say. Uh, See, first of all, remember that any property of the system, it is a point function, it is a state function, it is independent of the past history, it is the exact differential. These are the four characteristics of the any property. So one of the point is what? It is a point function. Getting my point? That property is of two type, intensive and extensive. Is that clear? No, that is a different thing. You are saying that is a different. That we say in terms of point function. At a particular point, we can define that property, right? But if we say work and heat, that depend on the path function. That is not the point function. If you change the path, work will change. Adiabatic work is different. Constant volume work is different, right? Understanding or not? So at a particular point, you can't say work. Suppose PV is there, right? Suppose you are saying constant pressure, constant, let's say, temperature process 1 to 2, 1 to 3. Work done will be different, right? Work done will not be same. So you can't say 1 to 2, 2 to 3. The work will be work equal to 3, you cannot say, right? And it is not a point function. That's why we cannot say dw, we can say delta w. That is the meaning of point function and path function. It is not like point means we are not worrying about the mass and size and all. No, it is not like that. Getting my point? Is that clear? So little bit of thermodynamics you have to read to have clear understanding of those things, right? Okay, guys, thank you. And whatever the further doubts will be there, we'll make sure that we'll be taking in our next session, right? Thank you all.